Ultimately, this is about changing facade connections to steel structures. We've been doing the same thing for about 70 years in steel construction to support facades. And so now there is something new that is available to us to be able to change the standard detail that we've been using at slab edges with steel structures. So we're going to look at the traditional facade connections to steel structures. And then we're going to talk about this new thing that has not been seen in 70 years, this change in the detail at the slab edge. It's associated with J-edge anchor testing. We're going to talk about the testing information and also the system advantages that are associated with J-edge. So we're going to look at the traditional facade connections to steel structures. And then we're going to talk about this new thing that has not been seen in 70 years, this change in the detail at the slab edge. It's associated with J-edge anchor testing. We're going to talk about the testing information and also the system advantages that are associated with J-edge. Well, let's start with some of the traditional facade connections to steel structures. So for a brick facade, this is a typical detail that we would be looking at for attachment onto a steel structure. We have a bent plate pour stop that's at the slab level, and some way we have to be able to support a ledge angle. Usually this is in some sort of a welded assembly, whether or not there is a standoff with some tubes or some framing out in the front. Either way it goes, it's typically field welded associated with any ledge support. Some of the limitations associated with this are the field welding is a high labor cost, and it also is a very time expensive labor cost. In other words, it drives up the end user date associated with being able to open the facility. So this would be another typical detail that we would see associated with a steel bent plate type edge detail. Sometimes these are hung a little bit down and it creates a ledge angle support off of steel tubes that are maybe every 3 foot. For precast, we would be looking at some type of a detail that's like this, where we have an embed angle clip with an embed design. And usually this supports high loads at the edge of the slab. And so a lot of times you have extra reinforcing associated at the slab edge to develop those high loads. So some of the limitations associated with this on the steel construction is the special embed that has to be used at this location, and also the loss of real estate. There's typically a setback that's required for this embed and anchor location. For some lighter weight facades like metal panels, this would be a common detail that we would see. Again, we have the steel bent plate with the slab edge. And so some way they need to have an attachment mechanism for the clip angles that support the cold formed steel to the bent plate. There's about half and half of these that end up being some shot in pins that are associated with it, or this can be a welded clip connection. So either way it goes, there's limitations associated with that. If it's power fasteners, there are some considerations associated with the longevity of the cyclical wind loads, because ultimately what happens is whenever they shoot this in, there's concrete that is back here. And so if the pin goes all the way through like it's supposed to, there's a question of refusal and whether or not it gets partially refused. So there's a little question about the longevity of these types of fasteners. So many of the fastener types we see there are a welded clip fastener. And again, you have the limitations associated with that due to field welding and the high cost and time associated with that field welding. For glazing systems, usually it will be some type of a clip angle support that's associated with it. And this is a stick-built type of a detail. And so we have clip angles on either side of the mullions. And so usually these clip angles are field welded again to a steel bent plate that is supported off of the steel structure. The limitations again are associated with the field welding, the high cost and time that's associated with that field labor. Sometimes we see embeds that are associated with steel structures. And so this is a detail of one where you have the bent plate again at the slab edge, and they actually have to cut through the bent plate. And you can see a picture over here where they have to have a box, a form box that is set up for the embed in the top of the slab. And there's welding that occurs. There's the steel that has to be cut. There's very large embed anchors down at the bottom that you can see. And there's additional anchors that have to be designed that go back into the slab. All of this has to be done with a lightweight concrete, which is not really good for structural connections. And that's why there's such an effort to develop these types of loads. So this is very costly to do with steel construction and lightweight concrete slabs. So every once in a while we see a detail that's like this. This is very rare, where you would have an embed channel that is actually part of the bent plate closure. This is really not doable. We rarely see this. And this would still require cutting of that enclosure bent plate and welding associated with that too. So 70 years approximately is the time that we've had this same detail for steel structures with a bent plate. This is actually 50 years old from the Kansas City area of the Flash Cube building that is downtown. And so it kind of shows the curtain wall, the glazing system on the outside. You can see clip angles underneath the slab, the same bent plate that is anchored back up into the slab, and there's welded clips. That has welds the same way to that bent plate forestop. So for 70 years, we've been dealing with the same detail. And that's the problem. This bent plate that is used at the edge of steel construction forms a barrier to anchor connections. And the only way to be able to attach to that barrier is by field welding or by cutting away part of the bent plate for embed anchors. And so we're working around this barrier situation to be able to get facade connections back to the structure and loads back to the structure. That's where this concept came from originally. We discussed with many glazing contractors out in the field, what are the main problems that are associated with the traditional construction? And almost to a T, they came up with field welding is the biggest problem that they have, with the most mistakes made. And so we took that upon ourselves to kind of develop and think about a better way of doing something. So this is a continuous pour stop with an anchor that is integral to the pour stop. And it's called J-Edge Anchor System. So some of the system advantages we'll start getting into now for J-Edge Anchor System. One of the great benefits that we see associated with J-Edge is it's much stronger. It has more load capacity than the standard bent plate at the slab edge. Part of that is due to a better load path because we have a reduction in eccentricity. So the typical wind load or connections would be welded on to the upper parts of this bent plate, and that induces a bending stress down around the bend due to the eccentricity of the load. For J-Edge Anchor System, it is a concentric reaction that we have. It gets rid of all of the bending stresses associated with it. Because of that, we have a greater capacity, about 150% increase in capacity just because of the better load path. In addition to that, we have stronger steel, which equals more load capacity, about 60%. So the traditional bent plate would be about 36 KSI yield strength. Due to the new extrusion techniques that they have, this is 60 plus KSI material for J-Edge anchor system. And so this is a 60% increase. So these two items together give over 200% increase in capacity over the traditional bent plate pour stops that we see. Here's a mill Cert where we show that it's above 60 KSI, so we're getting that stronger strength. One of the things that is very interesting about this is that it's a new process. It's relatively new in the industry, and it's a process of magnetic induction extrusion, and that equals a stronger steel. There's only a few places in the United States that's capable of extruding this type of steel product. Most of the steel that you see that's on a job site are typically rolled type of steel shapes. There's a lot of anchor testing that has been done associated with this system. Kansas City Structural Steel has provided for that. 3 different tests at KU Engineering Lab. There's tension test to just gauge how much tension can be placed on J-Edge. And then there's shear test to test and see what the capacity would be for supporting facades. So both of those tests ran out very, very well. For the tension only test, we were able to get up to about a mean of 28,000 pounds. And you can see that the average curtain wall load for a clip angle is typically about 1,000 pounds. And so we're well down below that load curve on the far end of that to where it's good. In addition to that, that shear testing was performed. We were able to get up to about 20,000 pounds on average with this shear testing, and that creates about a 2% offset. We can kind of see where it started yielding above the 12,000 pound line. And so our dead loads for a typical curtain wall would be about 400 pounds per clip angle, which is way down here in the bottom part of this area, well beneath what the testing came out at. Some of the other system advantages that J-Edge has over the traditional bent plate are it's an adjustable, bolted, continuous connection around the exterior of a building. And this allows for the avoiding of the costly field welding, all the equipment that's associated with that field welding out in the off to the side of the building, the lifts, the inspection, the safety efforts that you have to go through for field welding. It reduces anchor installation mistakes, which was one of the common items that we got from our team of facade contractors. This is a picture of J-Edge anchor system for the Waddell and Reed building that's going in downtown. We were in the shop of the fabricator, and you can kind of see it. It's actually offset by 90 degrees. Here's the beam, and it's already fabricated on the beam. You can see the welds of the J-Edge anchor system, and you can also see a clip, some pre-installed railing clips that we're going to discuss as one of the benefits in just a minute. Now, I have a video that is associated with it, but one of the things I wanted to be able to address here is one of the advantages that is really important is the reduction of all of the field welding, which is about 15 minutes per clip angle for curtain walls. That would be a half an hour per mullion. And so because of that, it speeds up the time of facade enclosure and the time that you may be able to open up the building earlier. It reduces the mistakes, again, with the adjustable bolted connection. So here we're going to get into a little video.
That's fantastic. So could you ship it around the U.S. like this?
Oh, yeah.
So you just fabricate it here and then ship it?
Anybody could, you know, that's a good fabricator.
Okay.
So this is a canopy or something that
That's a frame. The building actually rotates floor to floor as it goes up.
Oh,
each
really?
floor, yeah, rotates above each other.
Yeah.
So that's just the overhang.
That's an overhang that just sticks out there.
All the way to the length
Part
of the building.
roof. Okay.
You see it tapers?
Yeah.
So one end starts the whole length of the building and it gets wide on the other end.
Oh, wow.
Wow, this is super cool.
He couldn't have done this out of anything else.
So in that video, you're actually looking at that J-edge from the top perspective, and there's those clip angles again for the handrail system, and we're going to talk a little bit more about that handrail advantage in just a minute. One of the great features of J-edge is that it's an extruded product, so it's very straight. The tolerances on this are just absolutely phenomenal. Whereas the bent plate is typically a very wavy edge in and out of the building, introducing to whatever contractor is providing facade very high tolerances that they have to adjust for. So this is the part that I was promising you about the handrails and the advantage that J-edge has. Now this is a typical bent plate detail at the edge of slab, and this is what they have to do for temporary safety railing for construction in the field. You can see that they have to weld on an angle to the inside of the bent plate. Well, what happens to the angle whenever they finish construction? It just simply gets zipped off and cut level with the slab, and that actually introduces some re-entrant corners into your nice slab where cracking can originate from. And think of all the wasted material associated with this cutoff system. All they have to do with it is to be able to waste it. So this is a picture of that typical construction where you see a bent plate, and that would be the typical angle that is welded off to the inside of that bent plate. With J-edge, there's those clips that I mentioned to you before that we saw in that picture, and those clips have bolted connections, and they allow for a keyed lock with a safety railing system that is reusable in the future and very easy to remove during construction. Here you can see it on the Shamrock headquarters building. You can see this is the J-edge anchor part of it, where you see that groove that goes along the edge of Shamrock headquarters. And those are the clips that are for the handrail system and the handrail that bends towards the inside of the construction. Another advantage that we can see with the same use of these clips is a temporary enclosure where we run a member floor to floor, and we're able to greatly reduce the time to have a temporary enclosure. So they hang a sheet across these vertical members and they have it. And so we see that as a possibility for the future of temporarily enclosing quick. Here's a part that I really want to expound on, and this is something that is coming up over and over again in facade construction. It's associated with the thermal advantages of J-edge anchor system. So there's a potential to be able to have an additional thermal break so that you don't have thermal bridging at your connection points for your facade. So thermal bridging is defined as an area or a component of an object which has higher thermal conductivity than the surrounding materials, and it creates a path of least resistance for heat transfer. And you can kind of see that in this thermal imaging of a system, and you can kind of see where there's a conductivity across those areas where it's connected. New codes and future changes drive home the importance of thermal breaks even more. And this is out of the April 2020 Glass magazine. It basically indicates that ASHRAE 90, the 2019 version of it was approved in October 2019 and set into place. And it also said that on the horizon for the next time around are thermal bridging requirements, which is going to be dramatic whenever we see all of the connections that are supporting facades. And so it goes on to say that identifying and addressing the thermal bridges on a system will improve the whole system performance. And a little bit more out of that same article, it says you can have the best glazing system that there is out there, but if you ignore the facade connection points, it won't meet the goals. And this is where thermal bridging happens. So the importance of thermal bridging is going to be critical in the near future for construction all over the place, and we're going to have to be aware of that. So some of the advantage that we see here, now this is the standard bent plate, and this is a situation where we have some thermal bridging that is happening because we have a welded on system that is supporting and so close to the outside system for the support of brick. So what can you do about that? Here is an example of a thermal model using therm associated with where you have a ledge angle that has no thermal break. You can see the inflection points and the conductivity across that versus a thermal break over on this side. And you can see from thermal imaging just the traditional construction where we have that point of the ledge angle and its conductivity in the thermal image. That's with no thermal break. And so there is high thermal bridging that's occurring at those locations. So J-Edge does have a solution for that with the introduction of an additional structural thermal break and the bolted connection that introduces a reduced thermal load path or reduced thermal bridging. And in the case of the traditional facade support where we have a top of slab embed, I wanted to cover this because it's very important to see that usually whenever we have the metal that is aluminum out here, there is some type of an inboard piece of metal inside of the mullion system and anchors into that, and there's direct thermal contact and thermal bridging that happens. And so you have thermal conductivity back into your slab associated with these types of details. So J-Edge anchor system associated with unitized over here with a thermal break is much more superior to this detail where we have a thermal bridge. In addition to that, solutions for the unitized curtain wall system also have the thermal break material capability added in. Now let's take a look at some of the other possible advantages in the area of embodied carbon. So the carbon footprint has been a high importance item in architecture for a long time. One of the possibilities that we see that is coming out of the new systems of glazing systems such as curtain wall is a toggle set system with the glass. So it makes it possible for a SSG system to actually be removable where you don't have to actually remove the structural silicone. And so these become removable from the glazing system, and this becomes movable so that you can adjust parts and pieces in your exterior facade. Does that equal the possibility of reuse in the future? I believe that it possibly does. So you might go from something that looks like this on the exterior of a building and in 10 to 15 years revise it with newly adjusted members that support about the same tributary width and maybe some metal panels and stuff like that, where you're able to kind of reutilize the whole system. So there's also some improvements for support in handrail systems. Glazing systems either interior or exterior. Typically, these types of systems have an angle support that is welded, field welded to a bent plate again. So instead of that, we see the possibility of having a bolted connection, which speeds and reduces the cost. We also see improvement for support of precast systems, whereas we had with the traditional facade where you had that bent plate and we had the embed anchors up in the top of the slab and the loss of real estate associated with that. We're able to move this all outboard, and we're able to use a bolted system to be able to support that precast. You don't have the loss of real estate. It improves support options for masonry construction. As we indicated before, here's some of the details that we would be looking at for that type of support, where we have a drop-down support to a ledge angle for masonry. And we could have a screwed bolted system over here and the J-edge anchor system up at the slab level. Whereas we would be looking at field welding again, and the high cost and the time associated with that, with the traditional facade. For lightweight construction and facades, for metal plate, metal panels and other types of lightweight construction, we would be looking at cold form steel studs. And instead of the pin connections or the welded connection over to the bent plate that is traditional, now you would have either the bolted connection or you have a positive fastening condition where you can actually have no concrete behind your steel. Here's the real test of it though. It's the cost. So this is the big question. What is the cost scenario like? Basically, it's much better for J-edge anchor cost-wise than the traditional bent plate. Here's the reason why. Because there's an increase in the cost of the part right now, but the deducts that you get from the field welding way more than offset the increased cost of the part. And here's a real example off of a medium-sized office building. This is based upon Shamrock headquarters. The increased cost of J-edge part versus the bent plate was about $92,000. There was about a $200,000 deduct for the curtain wall installation because of the lack of field welding. And that created $108,000 in cost savings to the overall owner and to the GC. They were able to utilize those cost savings. This doesn't include savings that you would get for the reusable safety railing, the faster construction schedule, the value of potentially opening the office 1 month earlier. Now here's another video that I wanted to show. This is of Shamrock headquarters.
J-edge is great for pre-glazed curtain wall like this. It's even better for stick-built traditional curtain wall. I mean, a job that is just conventional, say Conair 1600, Tube Light 400, something with welded, typical wind load, dead load anchors, the J-edge is absolutely perfect for. You can fly. I mean, you can literally go through and you can put on 20 clips in an hour's time.
In that Shamrock construction, this was the edge of slab detail that was utilized. So you can see the J-edge. There's also an extension piece that is welded onto J-edge, And that's how it becomes adaptable for any slab depth. They have a weld-on piece that extends up to the top. In some cases, it may not be necessary. You may be able to have just a form that goes across the front part of the J-edge anchor system that forms it out. But in this case, we did have an extension. And so you can kind of see that hook that supports the unitized curtain wall system for Shamrock. And in that video, we saw those J pieces. These are the J hooks, and those J hooks allow for vertical adjustability of the system and an outward adjustability, and in and out of the page adjustability for the unitized system. And ultimately, this would be the type of detail that would be common. There's one additional detail that we'll see a little bit later on for unitized systems. You can see this is part of the railing system, the safety railing system, and you can see that behind the curtain wall after it's installed. This is extremely unique. No other system is like this, where you have a removable safety railing that can be removed after you get in the facade. And this is some of the adjustment that occurs on the inside. We can see that they've got the lift from the outside with the mega suction cups lifting the unitized pieces into place, and they have a little adjustment setting. And we're going to see this in a video in just a minute, how they set this into place. And here's the video.
Like right here, this is our wind load connection right here. And that piece can basically just float up and down with the curtain wall. Yep. And you can see it better, a double right there. That allows it to float up and down. We have an additional piece. It's a flat plate that goes over the top of those two plates, and then has a bolt that drills down into that aluminum clip just to sandwich it all together and allows it to ride up and down on the mullion. We just haven't started putting them on yet. And then we'll go up and we'll see the next floor up here in just a few, and that'll be your dead load location. Oh yeah, this is cool. All right. So, great thing about this edge slab is our attachment point on the edge slab is not vertical. So we can actually adjust the J hook off the J edge. We can adjust it up 3/4 of an inch and down 3/4 of an inch. And we try to get those clips set to elevation before we ever set a pin. Now, if for some reason we don't have enough elevation adjustment with the 3/4 up, 3/4 down, that's what these jack bolts are for right here. We basically loosen this nut, tighten the bolt head down to raise the panel up, back it off to lower it down. Nice. If the panel's not plumb or square, either way, you do the same thing. Adjust this side, leave the other side alone, or vice versa. Yeah. So that's your typical dead load location. So this right here, that's what they call a chicken head horizontal. Yep. And you've got a expansion horizontal that sits down as small as this whenever we go to the next floor up. So you're dead loaded up the floor line, and then right here, the expansion horizontal is taking up all the building reflection. So we're dead loading every floor, and then taking up the horizontal. That's true. I don't know if you can see. It's hard to see because we've got these all taped up. But this bracket right here, it allows us to move out 3/4 of an inch and move back in 3/4 of an inch, which is huge compared to, a typical wind load, dead load anchor, And we're actually able to take these J hooks and shim them off of the J edge up to a 1/4 inch out from the face of the J edge, so we can do some of the adjustment and some of the layout of the panel before we ever set a panel. Right. Do you find that the tolerance of the J edge is better than a vent plate? Yes, it's a lot more consistent. Being an extruded piece like that, it's much more consistent than a vent plate. Also, too, where where you have, you know, oftentimes where you have two intersecting points of a splice or something of a vent plate, you know, you'll see a lot of roll back and forth of the vent plate, whereas this being extruded, it seems to be straight, a lot better of a splice. We even have certain locations where we're bridging across the splice between the two pieces of edge. And typically, you know, on a vent plate with Waddell and deadload anchors, if you had a mullion that landed there, you know, you got to make two system vent clips to keep them straight and have your bolt running pretty straight. So, yeah, there's definitely a lot of unseen advantages that you really can't understand until you've done it or used it. Very nice. We need to come look at these. These panels are about 18 foot tall here. Yeah. And then the next floor up will be 15 foot as a typical location. These panels right here are 27 feet tall. They span 2 floors at a time. So we're basically closing in 2 floors of the building at once before we walk away.
Pick it up, get it up here, and put it into place.
That's right. And then we're relying on the J-edge as a dead load location at the intermediate horizontal. And we have a 1-inch caulk joint built at the head and at the sill to take up any building movement. Right now they're setting a panel. They're utilizing jack bolts that are bolted to the edge, and they are adjusting the panel to elevation. You watch, they'll disconnect the cup. Once it's fully locked in, you can tighten up the jack bolts right now once he's set to elevation. Okay, Kevin, we're good. He's going to come over and disconnect the outside. You can see down in the corner, the J-edge is mitered each direction. We have this corner that's going north-south, and we have this corner going east and west. The J-edge is mitered in the corner, so you can use a mitered clip. This mitered clip is typical throughout every floor, all the way around the building. There's no custom clips per corners or odd geometry. It's a square corner, and you're going to utilize a square bracket attached to the J-edge. It's very simple setup. It's great. It's unbelievable how easy it is and how it works. I mean, shoot, this is such a better setup than having to do blockouts in the edge of the slab or casting in things, doing embed drawing, doing embed engineering, embed layout. I mean, I don't know that I've ever seen a job that had even a 70% success rate with embed locations. I mean, it's just so much to coordinate.
What do you think the GC's evaluation is of J-edge?
In my opinion, I think they would have great things to say about it. I mean, it's saved the owner quite a bit of money. It's saved all the tradesmen a lot of money and a lot of time. It's much more user-friendly to have it continuous across the building. And you know, other projects where you have curtain wall coming into precast, I mean, there's no reason why you couldn't use the same exact attachment point completely going around the building envelope.
Well, thank you for bearing through that long video. Back to this. This is actually another installation at 46 Penn Center in Kansas City. You can kind of see it from the early parts of the construction. You can see this little edge around here. It has some little frame out points, and that's J-edge anchor system that is involved in that construction. Here you can see it a little bit better going around the edge of the building, and it's that groove that you see in there for the J-edge anchor system. And then this is some of the facade. Beautiful facility whenever you go down and see it on the plaza. This is some of the construction going on. They have a piece of glass that they're installing into. Now this was a stick-built application, so it's a little bit different than a Shamrock. They used stick-built, and then they installed the glass onto the sticks that were already constructed. This is the J-edge Microsoft building in Washington, Redmond. And so this is a detail that's associated with that. You can see the J-edge anchor is located off of a steel beam, the top of beam. This would be a typical detail for a unitized system again. We can see the chicken head that is up at the top here, allowing floor movement story to story. And adjustments in and out of the page would be at this location. Vertical adjustment would be at this location. Here's a top view of that same detail, showing how it rests upon a bar that's that runs across for adjustment. There's your vertical adjustment point, and here's your horizontal adjustment in and out of the page. This is the future Waddell and Reed headquarters downtown. Beautiful rendering that we see there. It's actually in the early stages of construction right now. This is the detail that's associated with the slab edge for a J-edge anchor system. Again, this is a unitized construction for a curtain wall out here. And we see that there is a bearing point with an adjustment bolt so that they have vertical adjustment. They have their horizontal adjustment taken up over here at this location. So on our website, for J-edge anchor website, we have sample calculations that are available, testing documents, we have AutoCAD files and RESELL files. We have some information about the J-edge anchor bolt that sits inside of the channel. And we have some more information about the reusable safety railings. There's also multiple videos that are available. Some of the construction videos, if you want to go back and watch, there's a lot more in the construction video area. So we can see that it is better structurally. J-edge is better than the typical standard construction that we've been using for 70 years on steel structures. It's better structurally, over 200% capacity increases. You have advantages for construction associated with thermal, with embodied carbon, with the ability to be able to utilize for all of the different facade connections to be bolted instead of welded construction at the bent plate. That creates the ability for a faster construction schedule, up to a month faster than having all of the field welding associated with the typical bent plate detail. And it saves construction cost. So ultimately, we've been using a detail that is outdated for 70 years. And so this is a call to action for a change to that detail. It's better than the traditional detail. What projects do you have that you're working on where this could work? So I'm going to take questions now, if you have any questions.
Stuart, this is Dick. Impressive system. I love the flexibility of it. The features like the railing and so forth, and the thermal break features that are offered. The question I had was, and I just saw it, I think, in a couple of the details, but it looked like on the photo that you showed where they were fabricating the Waddell and Reed beam with a J-edge attached to it in the plant, and also on the Shamrock plant, they had attached the extension to the top leg of the J-edge to accommodate the slab thickness. So is that I assume that this extrusion is of one size. And
yes, that's
for a variety of slab thicknesses, what if the slab thickness is less than the height of this extrusion?
Yeah, so I think, Dick, your question is about what is a slab thickness that the extrusion will fit to, and that's about a 4.5, 5-inch slab that it fits for just the extrusion itself without an extension to the top of it. Okay. And ultimately, that is governed by a maximum diameter that they can push through at this point, the die, for the extrusion.
Extrusion process, yeah. that
Yeah,
makes sense.
yeah. They're working on getting some bigger and better dies and a bigger, better capacity for pushing billet through with the magnetic induction process.
So you either weld a plate to the top edge, an extension plate to the top edge of this extrusion, or you could bolt, as you said, you could bolt a plate or some sort of a form to the outside and then remove it after the slab was poured.
That's correct. Yeah. So
That you could use for the screed, in fact, of this when they're pouring the slab. Yeah.
yes. Yeah. So ultimately, that is correct. We can potentially have some form that is on the outside of this as a temporary form that is
Right.
bolted on, and that can form a slab edge. So typically what we would do in that case is where we have reinforcing that still needs to attach onto it, and it doesn't need to in a lot of circumstances where we have loads that are very low. There's a very, if it's a very minor amount of load that is used in the curtain wall system, which most of the regular wind zones can qualify for. It's
Right.
it's the corner zones that we get into needing to have a little bit more there for the rotation effects. So that's where we would have a welded rebar that would come down and bend and be welded on.
That was, you just answered another one of my questions. Is additional reinforcing still required when they use this system? Are you commonly seeing this extrusion welded to the beam in the plant before the beam arrives at the job site?
Yes, that's the typical application for it, and that just it increases the construction so
Sure.
much. It's just so fast. And we're actually, whenever we were down at the plant visiting with the manufacturer of J-Edge, in the videos, he basically said that this is going to be a game changer on the Waddell and Reed building. We're going to actually film that and see how fast this whole thing goes up.
Good, good.
Yeah, good questions.
I've watched the painful process of the guys trying to locate clip angles accurately and field welding them, and then having to cut them off because they were mislocated and they weren't in the right place for the mullions. I love the horizontal adjustability of this, in addition to the vertical adjustability, with the horizontal adjustability of being able to move those clip angles from side to side when they start putting that mullion in place. It's just going to be amazing.
Yes, that's what we're counting on.
I really like
That's what
that.
we're seeing already. Yeah. Great questions.
It's easy to accept those labor savings cost estimates that you put up there. It's very easy to accept those numbers. I have no doubt that those are accurate. And maybe conservative. Yeah.
Yeah. And, ultimately, as I indicated before, that doesn't really count, all of the costs that go into, the savings on just the steel that is wasted on those temporary handrail systems.
Yeah.
Just to be able to reuse that over and over again on a construction site. So, there's definitely tremendous advantage, even cost-wise.
This system reminds me, of course, of Unistrut and all the flexibility that comes with Unistrut. I mean, it's the same thing here. And, I think we're just scratching the surface of what can be done with this system.
I believe that's the case as well. Whenever I saw that there was that barrier, whenever I heard the feedback from the glazing contractors in the field that their biggest complaint was, having to field weld, the clip angles or whatever attachment to the bent plate that we'd been using for 70 years. That really brought it into perspective that something needed to happen to help that situation out. For a concrete construction, they already have embeds that have anchors that are, embedded into the concrete.
Yeah.
And so that's the reason why concrete construction has kind of taken off in advance of steel construction, and that steel has just kind of been hanging back there. It's because of this, because it's so difficult to hang things off of.
Have you noticed on those projects where they have added the the extension of the upper leg, have you noticed any issues with that extension plate staying straight when it's welded to the top edge of the extrusion?
We haven't yet. I mean, it's it hasn't been seen that, you know, there's any problems with it. So, yeah.
Yeah, sometimes just the, you know, just the welding, if it's not done correctly, it'll just produce some waviness in the member.
Yeah, one of the great,
As I saw, they look straight as an arrow, though, of the Waddell and Reed and the Shamrock project. Those, it looked like they had done those extensions, and they look straight as can be.
yeah, one of the neat things is it's all done, you know, it's very controlled in the shop.
Right.
So
Right.
you don't have the, yeah, and they're able to grind that all down and do it in a very controlled process. Yeah.
That's a pretty heavy duty slab right there. That looks like about a 10-inch slab they've got going on.
Yeah, I think that this one was a very deep one. If I remember right, I think it was like 9 inches. But
Yeah.
see, that's another thing. That's another issue. You don't have to have a super deep slab anymore, because a lot of that is for transferring loads
Right.
inside of the slab. And so this really kind of frees things up if, you know, the structural engineers will start to take advantage of it.
That almost looks in that photo like the extrusion is welded to the edge of the top flange rather than overlapping it. Is that what I'm seeing there?
Yes, it is. Actually, it's welded onto the top of the flange instead of overlapping it. And so this would be one of the standard ways, and they have an outrigger that they've welded on there too. It can be overlapping the top of the flange, though. That's one of the, whenever we start to get out beyond that, that's whenever we have to have some other systems of support. And so we'd see outriggers out even beyond that. Very good questions. Are there any other questions for today?
I have no more. Oh, I did have one more. These are all threaded, bolted connections associated with this system. Is there any way, or are they locking these nuts at all, or are they just tightening them down and letting them go? Is there anything they're putting on there to assure that the nuts don't loosen over time with the, you know, the comings and goings of the facade and so on?
Yeah, there's provisions for installing either lock nuts or some, you know, locking mechanism.
Okay.
And it's based upon specification. Now, one of the things that we did, it's interesting for the Microsoft Office area, we actually created a slip critical connection. And what that means is it's designed to not slip during seismic events based upon the high tension capacity of this T-bolt. It's designed exactly like non-slip critical bolts in steel structures. And so it carries a load that is permanent tension across there, has a locking mechanism, and is able to create that surface compression enough to have that resistance laterally.
Interesting.
Whereas, you know, with the typical embeds, you don't have a fang surface. It's malleable, thin steel, and you don't have that capability of being able to create those types of connections.
Thank you.
Thank you all very much. I really appreciate your time. Thank you for tuning into this. If you have any questions, please feel free to email me at info@jedgeanchorsystems.com. Thank you.
Thank you.